The first sign of trouble begins inside your own walls. The wooden framework of your house would groan, splinter, and violently buckle inward under a massive invisible pressure. If you survived the ceiling collapsing, you would wake up to a terrifying physical reality. Because Earth's mass has multiplied by 10, a 150-pound person now weighs well over 300 pounds. Your own muscles would barely be strong enough to lift you out of bed. Astronomers actually spend a significant amount of time looking for massive planets exactly like this. NASA's Kepler telescope has identified numerous super-Earths, giant rocky worlds scattered across our galaxy that we often imagine as our next cosmic frontiers. We picture endless, untouched alien landscapes waiting to be explored. But existing in a high-gravity environment like that would be agonizing. Your heart would have to work frantically just to pump blood up to your brain, and every simple step would risk a bone fracture. If our planet ballooned to the size of a super-Earth, we wouldn't inherit a sprawling paradise. We would instantly find ourselves trapped in a claustrophobic, crushing biological death trap. The structural integrity of modern society would fail immediately. Concrete and steel can only support so much mass. Skyscrapers and multi-story apartment buildings would crumble, unable to hold upright under the multiplied gravity. The natural landscape would face the exact same fate. Towering trees would splinter and collapse under the weight of their own branches as the increased mass takes hold. Over generations, the surviving vegetation would be forced to mutate into wide, stocky, thick-stemmed plants hugging the ground. The animal kingdom would undergo an immediate mass extinction. Lightweight, agile predators, like falcons dropping from the sky or cheetahs sprinting across the plains, would simply vanish. They simply could not function in the dense atmosphere and relentless downward pull. To survive this environment, humans would have to drastically mutate. We would evolve into much shorter, incredibly dense, heavy-boned figures. It would be an absolute biological necessity just to keep our internal organs from crushing each other. Thousands of years of human progress, agility, and modern engineering would be erased overnight. Our existence would be reduced to an exhausting, slow-motion struggle against the sheer mass of the dirt beneath our feet. To understand why we could never leave, we have to look at escape velocity. This diagram models the energy required to break free from a planet's pull. As Earth's mass multiplies by 10, that gravity well drastically deepens. Any standard launch trajectory simply hooks back down to the surface. This immediate orbital crisis would violently yank satellites, telescopes, and the space station out of low orbit, dragging them down to Earth. Take a close look at the sheer scale of this launch exhaust. Overcoming normal Earth gravity requires controlled explosions and massive amounts of volatile fuel. On a super-Earth, the required thrust multiplies exponentially. No known chemical fuel is powerful enough to lift a meaningful payload against that much mass. Current aerospace engineering has zero solutions for a planetary threshold this extreme. Every blueprint for a rocket, shuttle, or space station becomes completely useless, effectively ending all space exploration programs immediately. We would spend the rest of our history on the ground. A tenfold increase in mass creates an inescapable cosmic cage with no hope of evacuation. The same gravitational force crushing the surface also drives deep into the crust, destabilizing the tectonic plates that hold the planet together. The stable ground beneath our feet would fracture. We would witness catastrophic geological ruptures, with massive fissures tearing across the landscape at terrifying speeds. This pressure would trigger events like the Great Atlantic Rift. Entire continents would violently rip apart, tearing a massive gap straight through the ocean floor and directly exposing the boiling molten mantle underneath. What follows is apocalyptic. Billions of gallons of cold ocean water would rush into these chasms, pouring directly into the exposed boiling magma. The resulting steam explosions would effectively pull the plug on the planet, draining the seas into boiling sinkholes. Evolving denser bones or building sturdier homes to survive the crushing gravity wouldn't matter. The literal foundation of the planet would be actively tearing itself apart from the inside out. Even if the tectonic plates eventually settled, the ultimate planetary death blow is already taking shape thousands of miles underground, at the very center of the Earth. This cross-section reveals what happens under 10 times the normal planetary pressure. The immense weight compresses the Earth's interior so severely that the molecules of the spinning liquid outer core are forced to pack together and solidify. The spinning stops, and the core turns into a dark, immobile mass. Without that rotating liquid iron, our planet loses its vital defense mechanism. As the core hardens, the magnetic field lines that protect Earth flicker out and vanish entirely. That invisible shield is the only thing keeping the sun from annihilating us. Without it, violent solar winds would immediately bombard the surface. This intense stellar radiation would boil away whatever oceans survived the tectonic rifts and rapidly strip the atmosphere right off the planet. Just look at the scarred, barren surface of Mars. This is exactly the end state our lush, vibrant blue world would reach. A dry, scorched, and totally irradiated wasteland, completely incapable of supporting any form of life. We constantly search the stars for bigger, grander planets to call home, ignoring the razor-thin physical margins that keep us breathing. Earth doesn't need to be massive to be perfect. It is exactly the size it has to be to keep us alive.